talk about this. Ready? Okay, Brendan. So I'm not happy about this, that you're not here, but I'm going to deal with it best I can. Hope you come back and that you're okay. Hope you come back tomorrow. We started off with just one more to sort of end this discussion on these kinds of determinate and indeterminate limits. So we made a list over here again. Is that in view? We made a list over here. This is already in your book, and we have determinate ones and ones that are indeterminate. When these pop up, we want it to look like this so we can l'hôpital. So we're doing one more for the road before we leave this sort of behind. Y equals x to the 1 over x, and we want the limit as x went to infinity. So I think it started out like that. The limit as x approaches infinity of x to the 1 over x. So the unknown was in the exponent, so we made an equation out of the problem, took the ln of both sides in order to bring the 1 over x down, took the limit, and you can watch the rest of the flow there. So it's very much like the homeworks that we did. And we ended up, I don't know if this is visible very well at the bottom, but it's y equals 1. So I'll be glad to go over that example if there's any part you have questions on. All right, so goodbye for now to this topic, and we are going to do improper integrals. So everyone has waiting with a bated breath. Their comp books are all labeled, and we're just waiting. All right, I have to work in this little section here. All right, that's okay. Just tell me when. Hey, this is plenty of room. That's all I need. Improper integrals. The only thing that is different about the integrals that we used to do and the improper ones is the limits of integration. So let's remind you what those are. Those are these little numbers, the limits of integration. Here's one with a bottom integration of 1 and an upper integration limit of 2. So 1 and 2. And let's just, for fun, this is called an indefinite integral. So let's just calculate it. It's nothing new. Indefinite integral. The answer is a number, and we remember how to do that. So go ahead and integrate that. Remember, 1 over x squared is simply x to the minus 2. So when you integrate, you're going to add 1 to that and then divide by that new exponent and plug in the 1 and the 2. Did you do something wrong?
I forgot to integrate.
Oh, you're sitting in that chair. Okay. So this is I'm sorry, I said this was an indefinite integral. Sorry, it's a definite integral because it has a definite answer. Sorry, so change that in your books if you were dumb enough to write that down. Definite integral, we're going to come up with a definite answer. Indefinite is when we have no numbers here. We've been working with indefinite for quite a while, so today we're going to go back to definite. So, anyone got an answer to that, and we'll confirm it off of one another? Gianni?
I got 7 over 8.
7 over 8. Anyone confirm or not?
Deny.
Pardon?
Confirm or deny.
Yeah, confirm or deny. We'll have a debate over it. What you got, Aaron?
Oh wait, I took the derivative.
Oh no.
I'm losing it today.
X to the minus 2.
Oh, yeah, I took the derivative too.
Okay, alright.
I took the integral, kind of.
Alright, kind of, but what you get? Kind of.
X to the -1 is, what's that?
Have you plugged in the
I forget
numbers?
what you put in front. Yeah, but is it negative x to the -1?
Negative 1 over x.
Negative 1 over x, right? With a 2 and a 1.
So it
you-
should
you
be
subtract.
1/2.
Ah, that sounds a little better.
Yeah.
Alright. Alright, so if you do this integral, and it should have been what? X to the minus 2. So when you integrate that, it becomes x to the -1 over -1, which is simply -1 over x. and you plug in a 1 and a 2, so we get a -1/2 minus a -1. So that does get us a 1/2. So we're happy? You happy with that? All right. Well, happy or not, onward. I would like to show you what that means, and that is the part, I think 1/x² might look like this. I know it looks like that over here, but we're not really interested on this side because we're looking at the area under this curve between 1 and 2. So let me switch colors here, 1 and 2. So it kind of makes sense that that area is 1/2. The way I've drawn it, it probably comes down and hugs the the x-axis a lot quicker than my sketch does, but that's what that means. The integral is the area under the curve between 1 and 2 of y equals 1/x², which takes on that kind of a shape. So, any questions about general definite integrals, what we're looking for and what we have once we find them? All right, the area under this curve. Well, what is really cool, peachy keen today is we are going to take this example, 1/x², and go from 1 to not 2, but guess what?
1/2.
No,
Pi.
no, we're gonna go.
Infinity.
Very good. We are. So we are going to find. We're just gonna make a slight change and change this to an infinity. So, does that make sense to your brain that we could find the area under this curve if we go out forever and find a number? Does that make sense?
No.
No.
It makes sense.
Did
just
I
not-
say-
It makes sense,
did
just
I-
not to my brain.
Yeah, but we will. So that's what happens when you deal with the infinite. It gets kind of mystic almost, but it's true. So 1 to infinity. So I have a hard time marking that on my graph. So if you know how to do it, you let me know. Here's how I'm writing it: 1 to the infinity. How you doing there, Jonathan? Do I have any more
Good.
board space over here?
Oh, yeah, you
Oh,
can
that's
write.
all I'm looking
Nice.
for. That's all I'm looking for. All right. So about how long do you think we've been on the video? Maybe about 6 minutes or so?
I have no idea.
Really? Okay, why don't you then shut it down and start it? I'd rather have a short one rather than a long one. We'll be right back. Okay.